Chapter 11, Lesson 5 on polygons. So the definition of a polygon is a simple, closed figure formed by three or more line segments, or what we usually call them are the sides. Okay, as you probably know, poly means many, so it's just something with many sides, and it has to have at least three. If it only has two sides, it doesn't form a shape. Okay, now I want you to pause the video for a minute and see if you can fill in your chart with all of the names of the polygons, the names of the polygon that has 3 sides, 4 sides, and so on. So pause the video right now and see how many you can fill in. Okay, now take a look at the names and see how many you got correct. I hope you got most of them correct. Now the 7 sides, remember that we can sometimes call that with an S a septagon, but usually we say a heptagon. And here are your other sides. Are the names of your polygons with certain numbers of sides? Now once we get past 10 and we have 11, 12, and so on, we just call it like an 11agon or 15agon, depending on how many sides it has. Now when we talk about the diagonal of a shape, the diagonal is a line from one vertex to another non-adjacent vertex. So we're going to, if we think about a polygon, 1, 2, 3, 4, 5 sides, here's a vertex of the polygon. A diagonal would be a line to one of the other vertices in that shape, but not one of the vertexes that is right next to it. So for example, a diagonal cannot be drawn here to here or here to here. It has to be to one of the vertices that is not adjacent to it. So diagonal could be here or here. Okay? Now an interior angle is just an angle formed at the vertex. So an interior angle of a shape is just the angle that is formed by the vertex. So that's an interior angle, this is an interior angle, and this is an interior angle. Now when I want to try to find the sum of the measures of the interior angles of any polygon, is what I do is I notice that my polygons can be, if we take a vertex and I draw all the diagonals, it forms triangles. And it always forms triangles that are 2 less than the number of sides. So this was a pentagon, 5 sides, it formed 3 triangles. So what I do is I take the number of sides and subtract 2, and then I multiply that number by 180 degrees because there's 180 degrees in the 3 angles of a triangle. And that's how I find the sum of the measures of all the angles in any polygon. So if there's 10 sides, it's going to form 8 triangles because I subtract 2, so 8 times 180. For example, if I wanted to find the sum of the angle measures, the interior angles in a nonagon, it has 9 sides, so I'm going to do 9 minus 2, and then multiply that by 180 because it forms 7 triangles when I draw the diagonals. Multiply that by 180, and I get 1,260 degrees. So that's the total of all 9 of those angles in a nonagon. If something is a regular polygon, what that means is that all sides and all angles are congruent. And we're going to use that in class to solve some more problems.